Hello, in this video we are going to see how to make a PolyHouse using a struts like thing in Etabs. And here we are going to, when we open the Etabs, here it asks for some settings, that is the display units. I am going to choose it as metric SI units, and the steel suction database Indian, steel design code IS 800 2007, concrete design code IS 456 2000. So I'm going to click on OK, and here you are asked to give the grid dimensions and the story dimensions. And here I'm going to first add the story dimension, and since here it asks in all in meters, first I'm going to leave it as it is, and I'm going to change the units. I'm going to use it consistent units, so that the length unit I'm going to change it to only feet. So now again I can change the story at the grid settings. So here I'll add the story, I'll modify and show. So I'll delete this, right click, and this also I'm going to delete. And here story 1. At a height of 12 feet. Now I am going to change the grid settings, modify and show grid settings, and here I am going to choose the spacing as for in X direction. Total is of 40 feet, so I am going to need only 2, that is 20 and 20. This one will be 40. And for this, for every 10 feet. This is 20, 30, 40 and 50. And then 10, 20, 30, 40, 50. Yes. And this one is 40. Okay. And then we'll click on OK. Here you are having the two different views. And I'm going to close one of the view, and I'm going to change the plan view to story 1. And here you can see all the grids. And first I'm going to go to the elevation. I'm going to change the unit. I'm going to go to consistency form. So I don't need any lengths. I need the length, so I'm going to change it to consistency unit. Here it is in Newton. Okay, I'll go here and I'll change it to metric SI. Afterwards again I can change. So I'm going to create new material, add for the steel, okay, and for the concrete M20 grade, add default properties, and new material I'm going to choose as steel, and now I'm going to give it as bamboo. As I said before, I'm going to choose the material type as steel, but which is useful for making the design at the last procedure. I'm going to specify the weight per unit volume in kilonewton per meter cube, which will be on an average of 7.8 kilonewton per meter cube, and the modulus of elasticity, that is in MPa megapascal, that will be around 16.5. So this is on an average value, since the bamboo varies from region to region and the data mechanical properties varies. So this is on an average value. So it will be, that is the Young's modulus will be 165 followed by 3 zeros. Yeah. And now it is proper. Since 165 into 10 to the power 6 kilonewton per meter square is the modulus of elasticity. So if you convert that into MPa, you will get 165 down, followed by triple zeros. And then we'll click on OK. And now we have defined the material. Now we'll click on define the suction properties. First, I'm going to add the column concrete RCC column property. That is, it will be column of 150 mm into 150 mm. That is 6 inches into 6. And here material I'm going to choose as M20, and depth has 150 mm and width also 150 mm. You can have a preview, and here the reinforcement I'm going to modify. Since it is the column, I'm going to choose the design type as PM2 M3 design, and the longitudinal bars I'm going to choose it as FE345 grade. And for the minimum clear cover for the confinement bars, that is will be 25 mm, that is 1 inch, and the number of longitudinal bars along 3 directional face and 2 directional face both will be 3 mm. And now we'll click on OK. And now we'll define another material, another cross section. There is bamboo. Here itself also I'm going to give the same material, and but for the material name I'm going to create, because it takes the property of this material which we have earlier created. And the suction tape is of steel pipe, the cross section type, and the outside diameter it is around 125. It varies, but for this one also I have taken as the average value. Even for the wall thickness I have taken the average value. It will vary from 15 to there are various dimensions, and click on OK. Right now we have created all the materials and defined the materials and the suction properties, and we are left with one more section. Since we are going to make the poly house, so I am going to define the slab as, I'm going to keep it as shell thin, and it is of, I'm going to use it of 200 microns thickness, so that will be around 0.2 mm thick, and we'll click on OK. And remember that name we are given it as slab 1. And now we are in the elevation. Right now I'm going to click on this draw beam or column brace. This is the quick draw where you can quickly draw using just by selecting the grid lines. Since we are going to draw the different things, so I'm going to use the draw option. So first I'm going to, and here I'm going to create an offset from this point. Since we are going to make the triangular structure, it will be, the height will be here. The height is around 3 feet from this point. Total is around 15 feet. This height is 12 feet, and this height will be 3 feet. So 3 feet, so it will be around 36 into 25, that is 900 mm in Z direction. So 900, I am going to choose this point, so it will be this point. And now I'll draw this and choose, remember to choose the proper property. Here I am going to use the column of 150 mm into 150 mm. And again I'm going to choose this, and I'm going to draw on this side. And for this side also I'm going to choose it again, draw. Now I'm going to change it to bamboo from this point, and from this point to this point, this point. And now to draw the bracing, that is the truss like thing. For the bracing things we are going to go to the edit frames and divide the frames. I'm going to divide it into 3, and then click on apply. After applying, you can see there are different points, and again I'm going to use the bamboo option. So I'm going to draw a straight line. Later you can trim those extra lines. I'm going to show how to use the trim option. It's not exactly the trim option. I'm going to show how you can delete those lines. First, I'm going to make like this. sorry, before that I have to trim. There's no option. First I'm going to select these two and this point of intersection. Go to edit frames, and here break at the intersection of the selected frame and joints, and then click on OK. Apply. Yeah. Now you can see these are the separate. You can delete it. Similarly for this side. Go to edit frames, divide frames, break at the intersection of, and then click on apply. Now we'll continue drawing the frames. From this point to this point, and again from this to this. Similarly for this also. Remember the material is bamboo. See this bamboo. To check the material, select the frame and then right click. You can see for this also you can just see this one, this column of 150 mm into 150 mm. Now I am going to change it to 3D view. Click on 3D view over here. Now I am going to select all. First I am going to go to now I'll select all this Control E, and now I'm going to use the option replicate. I'm going to replicate in Y direction. You can see the Y, X and Z. So for increment, now I'm going to use the units again as feet. Now I'll go and replicate in Y direction for every 10 feet, and the numbers are 5. And when you click on apply, you can just have the preview of it, how it looks, and then we click on apply. Now we are going to draw the beams. This is also bamboo, so first I am going to draw only one side and I am going to replicate it. You can just rotate the 3D model by using the shift and the wheel button. And here I am going to add one more purlin, and this structure, and then there is this frame is called the purlin in terms of engineering terms. And in between these two intersections, I am going to divide this again into two parts, so that again I can add one more purlin. So go to edit and edit frames, divide into 2. You can see the one more point has been added. Similarly for this I am going to make, and this also I am going to make, apply, and for this also I am going to apply. And for this also I need to divide. I'm going to select all the frames together for this side, and I'm going to divide it into 2 parts. Yeah. And now I can draw it easily. And now I'm going to add the other parts, like on this is done in y direction. For in x direction, I'm going to create this in the similar way. I'm going to select this. I'm going to rotate the model. I'm going to choose this and this top member and this. I'm going to divide it into 3 number of parts. I'm going to divide into 3. So yes, yeah. Now you can see, now again I'm going to add the bamboo from this point to this point, and from this to this, and from this to this, and from this to this. And now I'm going to select all these members which I have created, and I'm going to use the option replicate. Make sure everything is selected together. Now I'm going to use the option replicate. When you have already selected the members, so when you click on, now I'm going to use the numbers as 4. When you click on apply, just drag the cursor over, you can just have a preview of it, and then okay, yeah, done. Now the truss model are ready. Now I'm going to change the plan view to base, and now I'm going to select all the points, and now I'm going to assign the joint, that is the restraints. Since it is fixed, so I'm going to click on the fixed and apply, and then okay. Now I'm going to change back to 3D, and now I'm going to define the floor or the wall, and the property is slab, that is we have defined it earlier, and I'm going to make this side as well. Now I'm going to select these two, and again I'm going to use the option replicate. Just have, yeah, now you can see it has been replicated. Now I'm going to save the model. I'm going to PolyHouse using bamboo. So I'm going to save it as, giving it a name PolyHouse. But remember to keep saving the file as frequently as possible, because sometimes even if it does not overloads, it may get crashed. Now I'm going to apply the loads. For that, first we are going to, before that I'm going to define one more material, that is the section properties, that is the reinforcing bar size. See here they are the different bar size, but if you want to add, I'm going to clear all the bars, add a common set of bars. I'm going to use add SI, you can add, but here there is 6 mm and 4 mm diameter bars. This bar ID means there is a diameter, but in market usually 14 mm is not available and 6 mm is not available. So I am going to delete those 2 bars and then click on OK. And now here we are going to define the load patterns. Here by default dead weight it is there, live weight is also there. Now I am going to apply wind load, wind in X direction, and the type here I'll choose it as wind, and the code is IS 875-2015 for the loads, and similarly wind in Y direction, and add. Since I'm not going to add the earthquake load over here, since it is not mandatory, so I'm going to click on modify lateral load, and here I'm going to expose it to extents of diaphragms. So exposure from the shell objects, but I'm going to keep it as, and the wind speed is 15 meter. Here I'm going to leave the terrain category as 2 and the importance factor, and the height, exposure height is from the base till the story 1. Include the parapet because story 1 is at a height of 12 feet, but the total height is around 15 feet. So I'm going to include it. So parapet height as 3 feet. Let's click on. Similarly for y direction. And now we are going to select the members. So here I am going to apply the live load now. First I am going to select all the slabs. It will be difficult for me to select each and every slab. So I am going to use the option select. There we are having the object type. So I am going to select all the floors. So and then I am going to assign a shell load. This is a shell and uniform load. So here the units are different. So I am going to change it to metric S again. So assign shell loads uniform, and for dead load it is around 1 kilonewton. It is very less since we are going to use the bamboo. I am not calculated, but it is very less. It comes approx close to 1 kilonewton. It comes around 0.9. So I'm going to click on apply, and now I'm going to select the same objects, and I'm going to apply a live load that is 0.75 kilonewton per meter square, and that the direction will always be in the gravity direction, and then click on OK. Actually the dead load is quite too much, so I'm going to change it. I'm going to select the slab members, object type, floors, and I'm going to replace the existing load, dead load, with 0.75 itself. Apply. Here there are no frame loads, so I am not going to assign any frame loads. And here for the shell loads I am going to apply the coefficient. So it will be approx 0.8 to 0.9 in wind x direction also. So apply. So sorry, the objects are not selected. I need to select the shell. That is the walls, sorry, the floors. Apply, and in y direction also. This is how you have to apply the wind load, and now the everything has been done, and now we'll save it again, and we'll check the model for if there is any errors. So select all, and it will check for any errors in the model. And it shows model has been checked. There are no warning messages. No warning messages were generated. Now we'll click on analyze. So we'll click on run analysis. and you can see the displacement, how it has been displaced, and you can have the various reaction at the joints, and the ux uy uz, that is the displacement, rx ry rz are the reactions in x y and z direction at the joints. So if you can do the animation also, you can just click on start animation over here and just see how the animation thing works. And due to loads, you can see how these things are deformed, and you can stop the animation. And here having the option to display the joint load. Here we are not applied any joint load, so it does not show. And show the frame loads also, but here we have not applied any frame loads. So you can show the shell loads. See the shell loads in dead load has been formed, and the live load. And let us see. You can see the wind in x direction now. And now we'll just go to the show deformed shape, and here you're having different cases. For the dead load, how will be the deformation? For the live load, what will be the deformation? And for the wind in x, what will be the kind of deformation? Here there's no much kind of deformation. And we forgot one more thing. I will just unlock the model and we'll define the load combinations. There's a factor of safety we need to apply. I'm going to use it as dead load plus live load 1.5 times. If you want, we can just change it according to your needs, or you can use the standard one. And I'm going to use this itself. Here, if you say to add the default design combos, it will ask for which, for the steel, composite. There are different standard of safety factors, and for different design types, it will just go according to the code and the type of design. I'm just going to keep it as it is, and now again I'm going to analyze it. And now here we'll just see having an option called display spring or support reactions. Here you can see the support reactions. For the dead load, you can see, I'm going to select all the things. You can see all the values. Here you can see the tabulated. Also you can see in the tabulated view, you can have a better view, or I can have what is fz, fy and momentum. And for the dead load and for the live load you can have, and for the combo also you can have, that is I have created the load safety factor, that is 1.5 times the dead load, and live load you can have for that one also. You can choose to have which you want to see close. And here you are having the display frame forces. Here you can see how the forces are formed. I'm going to choose this frame links, and you can see the deformation. You can choose the axial force. This is for the dead load, and for the live load you can see, and for the shear 2 in direction 2 you can see all the members. In momentum also you can see, and torsion also you can see, and momentum in 3 also you can see. So after that, now we'll see display the shell stress or force, that is the shells. You can see the forces in the shells members. You can see the values. You can scale also given over here for the live load. For the dead load also you can see how the you can choose shell stress or shell resultant forces, and choose which are the value you want. We need to see, or you can see, or you can show the values also, so that you can take the values from here and use it for the further calculation or whichever whatever you want. And we'll go to the design. So I'm going to choose the design groups and select all. For steel members, I'm going to choose as steel frame design. Here we are having only composite beam, composite column, concrete and steel frame. That is the reason why I have chosen steel as the bamboo thing. So I'm going to choose the design combination combo one, that is 1.5 times the dead load and live load, and we'll just click on start design or check. Just start designing and show whether the member fails or not. You can see the blue mark shows that all the members have passed the design. Similarly for concrete, I'm going to choose the design groups as all and combination, and I'm going to click on start design or check. You can see all the members have passed. If the members have passed, if you want to check the members which have failed, you can just go here steel frame verify analysis versus the design section. What it will do is it will verify the analysis result and the design section, and it will shows that the design and the analysis sections have matched for all the steel frame. In here we are having the option called verify all the members are passed. It will show that all the members have passed or failed. Here it shows no error and all the steel frames have passed the stress capacity design. Similarly for concrete, here I'm going to verify all the matched analysis and the design for the concrete members have matched, and I'm going to choose verify all the members are passed. And here also it says all the concrete frame members are past the design. And when you click on analysis, run analyze, first I'm going to unlock the model, and here we are having one more option called, first I'm going to run the analysis, and when you click on the member you can see the deformation, and here after the designing of all the steel frames and all the concrete frames, and here you are having the option called detailing. I'm going to start the detailing where it shows all the detailing, but here it shows the proper detailing of the column. Steel sections, that is I have used as the I'm going to use as the bamboo. It starts that one also, but here I am having the option called steel connection design also. I'm going to choose the combination. It will not design it properly because I've chosen the material as bamboo, and the concrete and the bamboo. Here it does not have a standard procedures in the program. So if you want to design any steel structures fully completely made of steel, and here if you want to design a steel connection between a column and the beam, here you can use that option. Here it will just check, but design is not proper because you're going to use the bamboo that is a circular and the columns are RCC members. So here cannot show that properly. And when you click on detail, it will show detailing in progress. It will provide all the details. And it has been finished, and I'll use this. And here you are having all the standard drawing details. I'm going to now you are having all the things. I can see all the column cross sections. and here I'm going to have the column details. Sorry, I'm not able to expand it. And this is the detailer. You can have a detailing of all the things. So here you can just have a preview of it. And if you want to generate a report, you can just go to the file and create report. So I'm going to create a custom report and new user report. And here I'm going to name the report as the report of PolyHouse. And here you are having the different options to select the load cases and all the material details I want the load case details and active degrees of freedom, and the assignment I want the restraint frame section, insertion point, and the cell section I want, and the output I want the stiffness, beam, column force, and displacement drifts and forces, element joint forces. And I want all the design, that is all the stream frame, and for the concrete frame I want all, and for the steel connection I need all, and then we click on create. It takes some time because I have added most of the data. And here you can see at the left bottom, adding chapter 4 analysis result of 4 out of 7. You can see the progress over here. Sometimes it not respond because shows it is not, because too much of overloading happens. And now we can have our results. You see all the results and can just have a print out of it. Thank you for watching my video. Please like and subscribe my channel for more videos like this, and comment below for any suggestions.